Hello student. In the previous lecture, I have discussed about different elements in a feedback structure. Different elements of a feedback structure. In this lecture, I will discuss about negative feedback and positive feedback. What is negative feedback and what is positive feedback, and how we can derive transfer function of this negative feedback and positive feedback, and how feedback affect the parameter of control system, parameter like gain, sensitivity, stability, etc. So let's start today's lecture. Let's start our today's lecture. So if we see in a closed loop control system, if we saw any path from output to input, then we can say we are having feedback. Then how we need to ensure the given feedback is positive or negative. So here, if we are subtracting the feedback from input, in that case this is the negative feedback. Or if we are adding the feedback element to the reference input, then this is positive feedback. Generally, in feedback side, if you see negative symbol, it is called negative feedback, and if you see positive symbol, it is called positive feedback. Now coming to the transfer function of these two systems. So two system means negative feedback and positive feedback. So we know that the transfer function is basically the ratio of output transform by input transform with consider the input initial condition is 0. Here we have input transform is RS and output transform is CS. Now here CS is output transform and RS is input transform. So there is various name are there, where RS is reference input, CS is output signal, BS is feedback signal. This feedback signal line is indicated by BS. So BS is feedback signal, ES is actuating signal or error signal, GS is forward path transfer function, and HS is feedback path transfer function. So how we can derive the transfer function of this? So let's see how we can derive the transfer function of this negative feedback. The actuating signal or error signal is basically the output of the comparator. So how this ES is expressed? ES is expressed by RS, which is our reference input, RS minus BS. Minus, that's why, because here we use negative feedback. So ES is expressed by RS minus BS. BS is the feedback signal. BS is the feedback signal. And this BS is expressed by CS into HS by this equation. So BS is equivalent to CS into HS. By putting this BS in error signal, we get this equation. where ES is equivalent to RS minus CS into HS. So, after considering feedback signal, we can write this output signal CS equal to ES into GS, or this ES is RS minus CS into HS into GS. So, by simplifying this equation, we get CS by RS, which is the transfer function, is equal to GS by 1 plus GS HS. So, this is the transfer function of negative feedback control system. Okay. And if we consider the positive feedback, then the transfer function is like this. The transfer function of positive feedback is CS by RS equal to GS divided by 1 minus GS into HS. The difference between positive and negative feedback transfer function is only in the denominator part. Here, negative feedback, the denominator part is 1 plus GSHS, but in positive feedback, the denominator part we are having 1 minus GSHS. So this is the transfer function of positive feedback and negative feedback closed loop control system. The parameter of a control system may have a tendency to vary due to changing environment condition, and this variation in parameter affect the desired performance of a control system. So, the use of feedback in a control system reduces the effect of parameter variation, like gain parameter of the control system, like gain of the control system, stability of the control system, sensitivity of the control system. So, the term sensitivity in relation to control system gives an assessment of the system performance as affected due to parameter variation. So, in this lecture, we are going to discuss about the effect of feedback on control system. So, here we are having the effect of gain or sensitivity or stability. These are the three main effects due to feedback. So, on control system, gain, sensitivity and stability are the main effect due to feedback. Now, we are discussing these three effects one by one. First, we have seen the effect of transfer function parameter variation in an open loop control system. This transfer function means the overall gain of the control system. So, if we consider an open loop system, then the transfer function of open loop system means there is no feedback, only the gain block is GS and input is RS, output is CS. So, the transfer function of open loop system is TS equal to TS, which indicate the transfer function or overall gain, TS equal to CS by RS, which is equivalent to GS. This is the gain of the system. Now, if we consider a small change like delta, then GS is changed to GS plus del GS. After considering a small change, then GS will be GS plus del GS. Therefore, CS equal to CS plus del CS. So CS plus del CS equal to GS plus del GS into RS from the transfer function equation. You see the transfer function equation. If we consider a small change, so after considering small change, this output signal will be changed, and this signal is CS. After changing or after considering small change, CS is equivalent to CS plus del CS, and this CS plus del CS is equivalent to GS plus del GS into RS. RS is same. So after simplifying this equation, we got this equation where del CS equal to del GS into RS. So this equation gives the corresponding change in the output with reference to change del GS in the transfer function GS of an open loop system. Now come to the closed loop system. So if we consider closed loop system, then the transfer function or overall gain is, if we consider the negative feedback, then the transfer function is TS equal to CS by RS equal to GS by 1 plus GS into HS. Now if we consider a slight change, say del GS in the forward path transfer function GS, then changes it to GS plus del GS and let the corresponding change in the output be del CS. So the new output of the system is CS plus del CS equal to GS plus del GS divided by 1 plus GS plus del GS into HS and whole multiply by RS. After simplifying this equation, we get this del CS, where del CS is expressed by del GS divided, which is equivalent to del GS divided by 1 plus GS into HS and whole this del GS by 1 plus GS into HS multiply into RS. This equation gives the corresponding change in the output with reference to change del GS in the forward path transfer function GS of a closed loop control system. As 1 plus GS into HS is very greater than 1, therefore comparing equation A and comparing equation B, it is concluded that due to feedback, the variation in the output caused by the change in the forward path transfer function is reduced by a factor 1 plus GSHS. Whereas in the open loop system, this reduction is not indicated. Thus, the output variation is more sensitive to variation in GS in case of open loop system as compared to closed loop system. Now come to the point how feedback affect the overall gain of the system. Look at the transfer function of the closed loop system, because we have seen the feedback is only in the feedback is feedback we have seen the feedback is only in closed loop system. So we consider only closed loop system. Okay, so if we observe the transfer function of closed loop system, then we have seen this overall gain. Transfer function means overall gain. This overall gain is controlled by the factor of 1 plus GS HS. Okay, so if 1 plus GS HS is increasing, or if it is greater than 1, then this value means overall gain or transfer function, overall gain or transfer function is going to reduce if 1 plus GH is increasing. If 1 plus GSHS is increasing means GSHS is greater than 1 or GS is positive. So if GH is positive, then the total value is keep on increasing. Total value means 1 plus GS. If GS is positive, then total value means 1 plus GSHS is keep on increasing. And if this is increasing, the total gain of the system is going to decrease. That is, if you give positive feedback, in positive feedback GS value is negative, then the overall gain is going to increase. So when the GS value is negative, then overall gain increasing, and when GS value is positive, the overall gain going to decrease. So like this, feedback is going to affect the overall gain of the system. If the feedback path is increasing, the total gain or overall gain of the system is decreasing, and if the feedback path is decreasing, then the total gain or the transfer function of the system or overall gain of the system is increasing. So today I stop here. The rest of the two effect I will be discussed in the next class. Thank you, student.